The definition of a set is a collection of things. For example, the first 5 letters of the alphabet would be a B, C, D, E. Another example is first 5 natural number would be 1, 2, 3, 4, 5. And what I just showed you is represented by the listing method, or the tabulation method. The other method is to describe it by its property, or the rule method, where this is containing only element of x. In this case, x will be the element of a and b. For example, a set contains only even integers between 50 and 63. Using the tabulation method, we will get this, while with the rule method, we would get this instead. The rule method is just a description in shortened math form, where x is even integers between 50 and 63, and x is the only element of the set. And the rule method is even more precise than our normal conversational speech. Why? Take a look at this. Does this include both endpoints? Or not? Because 2 of them are both between 50 and 63, and that is why we have notations as brackets, where different brackets has different meanings. Squared one means closed. For example, x is between and equal to a and b. The left side means x larger and equal to a, and the right side means x smaller and equal to b. The rounded one means opened. For example, x is between but not equal to a and b. Left side means x larger but not equal to a. Right side means x smaller but not equal to b. And of course, we could have something like half opened, half closed, such as this. For example, all real numbers greater than 50 and less than or equal to 63. And if when enumerating the members is hard, we often use ellipses to show visually the relationships between different sets, which are called Venn diagrams. These are the iconic one, for example. The number of elements in a set is called cardinality. The number of elements in a set is called cardinality, which has an infinite amount of members. And then the finite set, which has a finite amount of members. Then there the singleton set, which has only one member. And we also have an empty set or null set, which don't have any member at all, which this symbol could denote it. But we must note that these two are not the same, because this one is empty, which has no member, while this one has one member, and that is the empty set itself. And so this a singleton set. And finally, we have universal set, which is on top of everything else. Basically, it contains everything under consideration. It contains everything, okay? By the way, this is called, is an element of, which means belongs to, and universal set denoted as capital U. So this sentence means everything is an element of the universal set. And sets can be elements of other sets. But universal sets could not be an elements of other sets, because everything is an element of universal set. And set, that is the element of other sets called a subset. A is a subset of B, if and only if. All elements of A are also elements of B. To visualize this, we could use the Venn diagram. For example, this is set A, and this is A is a subset of B. And this is if and only if all elements of A are also elements of B. If B contains elements that are not in A, then A is a proper subset of B. And if A is a subset of B but not a proper subset of B, that means B contains every elements of A but not elements that are not in A. That means B equal A. And in this case, while A is a subset of B, B also a subset of A. Every set is a subset of itself. So A and B are equal, if and only if. A is a subset of B and B is a subset of A. If C is a subset of B, and B is a subset of A, then C is a subset of A. The power set of the set S that has elements A and B is the set of all possible subsets of a given set, including the empty set and the set itself. Power sets were denoted as P with the set of its inside brackets. If a finite set has n elements, then the power set of that set would have 2 to the power of n elements. But why? If set S has n elements, the power set of set S would have null set plus n of elements from set S, and n choose 2 elements, and n chooses 3 elements, and so on, until n choose n. Write everything down and we get this. That would equal to this. See something familiar? Now just arrange stuffs. Let a and b equal 1, and that is where the equation came from. Thanks for watching. Please like and subscribe to my channel if you found this video helpful. Don't forget to leave a comment below and share this video with your friends. Your support means a lot.